All right. Hello, everyone. Welcome back to my channel. If you are coming from the previous video that I filmed and that I put out yesterday, um, then you might notice that I'm wearing the same clothes. It is not because I have not changed clothes. I actually am filming this one day in advance because I will probably be on a plane when this gets put out. So very exciting stuff. Um, Now, today we're going to be talking about using the cofactor method to find the inverse of a matrix. This specific example is a 3 by 3 matrix. However, you can use this method with any dimension square matrix. Awesome. So the problem is from the March 2015 comp exam, and it is question number 5. It says, let A, B, and C be distinct real constants. Use the cofactor method to find the inverse matrix of 1, 1, 1, ABC, A squared, B squared, C squared. So this entire problem relies on a singular formula, which is this. So let's say that this matrix is called A, right? In order to find the inverse of A, we need to find the determinant of A first. And we're going to say 1 over the determinant of A, and that's going to be multiplied by the adjugate of A. So we also have to find the adjugate of A. And I'll talk a little bit more about what the adjugate is later in the video, but we need to find these two things because this formula, right, is how we use the cofactor method to compute the inverse. So if you get to the test and you don't know this formula, you basically can't do this problem, right? Unless you memorize the process and not the specific formula, but it's really the same thing, right? So make sure you know how to do this, and we'll do it together, so you will see. So the first thing that we're going to do is to compute the determinant, right? And we're going to use the cofactor method to compute the determinant, right? Because what we can do is we can do 1 times the determinant, right, of everything in here, minus 1 times the determinant of the minor matrix, right? The minor matrix is everything excluding the row and the column of the thing that we're summing over, the row or the column, right? And then plus 1 times that determinant, right? So that's going to be the determinant of A. So, and these are ones, sorry, kind of looks like absolute value symbols. I don't know if this augmentation is going to help at all, but 1 times this, this, and this. So to compute the determinant of the minor, we can just use the determinant of a 2 by 2 matrix, right, is given by AD minus BC, right? So we're just going to do BC squared, where ABCD is the matrix, right? So that's a little confusing because we also have ABC in this problem, but you probably know what I mean. Cool. So BC squared, right, minus B squared C here, squared C. And then the next one, right, we're going to do AC squared minus A squared C. And then the last one is going to be A B squared minus A squared B. Awesome. So then 1 over, right, 1 over the determinant of A, and you can use the little bars to notate to denote the determinant, or you can use the DET symbol. I'm using both here. It doesn't really matter. That's going to be equal to this whole thing, and I'll simplify it now. That is going to be BC squared minus B squared C, right? Minus AC squared plus A squared C plus AB squared minus A squared B. And there's really not a whole lot we can do to simplify that. So let's just leave it as is. Now we're going to find the adjugate matrix. And this is the part that I believe is a little bit trickier, right? So to find the adjugate matrix, what that is we're going to take the sign matrix, right? So it's going to be plus minus plus dot 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 minus plus dot dot dot. So we're going to take that thing, right? And then for each entry, right, we're going to multiply it by the determinant of the minor matrix. So that is right. So this is not, they're not equal, but we're going to use this. So maybe I'll get rid of this equality sign. Hold on, sorry. We're going to use this, and actually I'll make it a different color. Yeah, there we go. We're going to use this, multiply the sign by the determinant of the minor, and then we are going to take the transpose of all of that. So it's a three-step process, right? So let's take a look at our matrix, right? I'll write it here again. 1, 1, 1. Oh, hold on, sorry about that. 1, 1, 1. A, B, C, A squared, B squared, C squared, right? Awesome. So the determinant of the minor, right? Let's compute that. So that's going to be BC squared, right? BC squared minus B squared C for the first entry. And because it's positive, we don't have to do anything crazy with that. For the second entry, right, it's going to be negative AC squared minus A squared C. But since that's one thing minus another and we're negating it, we can just flip what we're subtracting, right? So that's actually going to be A squared C minus A squared C squared. So let's actually make our thing a little bit bigger. That's going to be A squared C minus A C squared. And then for that last column on the first row, that is going to give us AB squared minus A squared B. And that is positive as well. So AB squared minus A squared B here. So I know that this is looking a little bit large, but it's still a 3x3 matrix. The next couple rows are going to be a little bit easier to compute. So this spot right here, right, is going to be negative because of the sign matrix. So that is actually going to be BC, nope, sorry, C squared minus B squared. But we're negating that, so that is going to be B squared minus C squared. For this next one, this is positive, right? And so we take everything that's not the row and the column of this spot on our original matrix, and we compute the determinant of that new matrix. So that is going to be C squared minus A squared, right? Minus A squared. And then for this one, we're going to do the same thing. And that's going to give us B squared minus A squared. But to make that negative, we're going to have to make that negative, right? So that's actually going to give us A squared minus B squared. Okay, wonderful. So now we're going to do the same thing with the bottom row. That's just going to give us here, right? C minus B, and that's positive. Here, it's going to be negative again, right? So that is going to give us C minus A, but negating that is A minus C. And then lastly, we are going to get B minus A, and that is positive. Okay, so we have computed that. So I will say the adjugate of A is equal to not this matrix, right? But it's this whole thing transpose. So the last thing that we need to do once we've computed the determinant of the minors, attach the signs on, then we have to take the transpose of all this. So that means that the adjugate matrix of A, right, that is equaled to, and then to transpose the matrix, we just turn the rows into columns, right? So row 1 is going to become column 1, right? So that is going to be this. And then squared minus A squared B. Awesome. And then row 2 is actually column 2, right? So that is going to give us B squared minus C squared, C squared minus A squared, and then A squared minus B squared. And then lastly, right, we're going to get C minus B, A minus C, and then B minus A. Awesome. Okay, so now we have found our adjugate matrix, right? We've computed the determinant. Both of these things are a little bit messy, but they can't really be simplified, so that's okay. And what we're going to do is we're going to multiply them, or I guess it's scalar multiplication, right? Because 1 over the determinant is a real number. But to find the inverse of A, we're just going to put these two things together. So I am going to be lazy, select this and duplicate it, because I'm now learning how to properly use technology. Duplicate, and then we'll just bring it. Oh, maybe I'm not learning how to use technology. Hold on. How are we going to do this? Can I copy it? Yes, I can. Okay, maybe copying it will work. So that is going to equal. How do I do this? You know what? I'm going to be not lazy and write it all out again. Okay, so that is going to give us 1. Oh, and I don't even have my pen tool. Sorry, it's been a very long day. 1 minus b c squared minus b squared c, b squared c minus a squared minus a c squared plus a squared c, right? Plus, I think it's a b squared, yes, minus a squared b. A b squared minus a squared b. And then what I'm going to do is select this and make it smaller, because this is a very big equation. And then now I can be lazy. I can take this adjugate matrix and then paste it right there. Wait, hold on. I don't want the equal sign. Aha, here we go. Okay, and that is finally the equation for the inverse of A, right? And we could technically, right, distribute the 1 over into it and multiply all of the elements by that, but it doesn't really seem like that would lead to any further simplification, so that would be a waste of our time. We can express it as such. Awesome. So this problem comes down to just knowing this equation, right? Because computation-wise, I'm sure you all know how to compute the determinant and also, you know, how to find the adjugate matrix. Maybe not, maybe that's a review. But yeah, as long as you know this formula, you should be set on a problem like this. However, if you do end up having questions, definitely feel free to let me know in the comments. And hopefully you enjoyed this video.